Hi, welcome to CreepGame Assignment 2.03. So here's the requirements. It says your engine should now support textures. Well, we're good on that because we added textures last assignment. Now it says you should support vertex and pixel shaders, so we'll have to add that. And you should do something cool in the shader, so we're going to need some cool stuff. Let's have a look. Here's our game. Let's run it. Choose a medium paddle. Get it all ready. Now I'm going to pause the game so that we can concentrate on everything else. I'm going to press N to show us the game from the side. Now you can see that the paddles and the ball have some kind of not only have a texture applied to them, but they have some kind of a weird shader applied to them too, which seems to be producing concentric holes in them. And let me start it back up a second. You might even be able to see that you can see through those holes. Let's see, there you go. You can sort of see right there. So the function used in that shader to produce those holes involves an x squared and a y squared, which kind of explains why they're circular. And the texture on there is a clown pattern, but you can't see very much of it. Now, if I turn on the outer boxes and zoom out a bit, you'll be able to see that pattern a little bit better on the outer box that I've got. So let me zoom out a couple of steps, and let me go up a couple of steps. So you see here that box there in the center is our Waterworld box, and you can see that the outside of the box has the shaders applied, but the inside doesn't. But anyhow, you get an idea there. Basically what we're doing is, based on that x squared plus y squared formula, we are deciding whether or not to turn a pixel on or off in the pixel based shader. So that's our cool pixel shader right there. Now let's zoom back in. Oops. And there's our game again. Now let's take a look at the stats over here on the left. Look at this, 63,000 verts. Now what in the world needs that many verts? Well, what we're going to do is apply a pixel shader to this black tabletop, Pong tabletop. Now normally a rectangle like that would only take 4 vertices, but because we're going to want some a complicated smooth function, we're going to apply a complicated smooth function to that tabletop, we want a whole bunch of vertices. So really we've broken this tabletop into a grid of 250 by 250 squares, and that's over 62,000 right there. So that's where all those vertices are coming from. So I'm going to press the P key, and we will start the cool vertex shader on that tabletop. And let's go. Well, there you go. So we've got a shader on there that turned it yellow, or I'm sorry, orange, and you can see specular highlights on it, and obviously there's some kind of a directional light source, and you see the pattern, the formula being applied to the surface of the tabletop is changing every frame, evolving. And let's just give it a few seconds till we see what it's going to do. Let's look at it from the there we see it from the end of the table. There it is from above. You can clearly see the rings and the specular highlights. Now notice those rings. They're kind of like the holes in the shader we just showed, the pixel shader we just showed you a second ago. And matter of fact, it uses the same formula, but there's a sine of x squared plus y squared in there, which produces those sinusoidal-like ripples in the function, or in the tabletop rather. Okay, so that's about, okay, so now we've basically reached the end of the changes. So that's about as ripply as it's going to get right there. So that's our cool vertex shader, acting on 62,000 vertex per frame, vertices per frame, sorry. I'll start it up again So you can see it. I might get unraveled about, I don't know, about 3 times as fast as it goes together. So anyhow, that's pretty cool. And not only is there the Vertex shader applied to the tabletop, but there's a pixel shader in that we've already talked about, and that provides the it has the directional lighting, diffuse, ambient, and specular lighting. Okay, so let's take a look at some code now. Press X to stop this. And so here is the code where I break up the, well, I call it a floor sheet here, break up the tabletop into a grid of 250 by 250. And notice this is being done programmatically, but if we were going to actually have that structure, that demo in the game, of course we'd want to do that offline so we wouldn't have to calculate it at startup time, but for now that's okay. So now let's look at the shader. So here's some shader code. Here's a function that gets used that does the sine wave plotting on that tabletop. Notice that a vertex position is being passed in right here, an XYZ. And the interesting thing is here we take the x squared and the y squared, and then we take the sine of that, and then we multiply it by basically an amplitude factor, and then we add a z translation to that, because we kind of want the ripples to mostly occur below the paddle on the ball, so that we can see the paddle on the ball. That basically just moves it downwards. And then what we do here is we actually modify the z based on this. So that's actually modifying the input. That's how we get the ripple effect, is that the z-axis is being modified by this formula here. And then what this function does is it takes the partial derivatives of this function at this vertex and takes the cross product of them, and it returns that, and that's basically what the normals are. So this function basically returns, not only adjusts the z value, it also returns a normal so that we can figure out lighting and stuff. Okay, so that's about it for my overview of assignment 2.03, and I'm going to leave the game running a bit for your viewing pleasure. Thank you, and goodbye.